Hi, this is section 5.4, values of trigonometric functions. So they start us off with the definition of a reference angle. So a reference angle is an angle that's, it's an acute angle that, and they're going to call it theta sub r, that has a terminal side of theta that it makes with the x-axis. So that's key. It's the angle that's formed with the x-axis always and the terminal side of theta. So let's look at some examples. Find the reference angle of these following angles. All right, so let's draw that. So if you draw that angle, that would be, I would recommend that you find a coterminal by adding 360. So let's add 360 to that. Let's see what we get. Should get 125 degrees. So 125 degrees, that's going to be somewhere over here, right, in quadrant number 2. So let's say it's about here somewhere. All right, so that is our angle. That is negative 235 degrees. We just found a coterminal angle, which is good enough. All right, so the reference angle is going to be the angle that's formed by the x-axis and the terminal side of theta. So there it is. And this is the terminal side of theta, and this is the x-axis, so this is our reference angle, theta sub r. So what we can do is we also know that it is equal to 125, and so we know this is 180. So in order to find this angle, you're going to take 180 and subtract 125 from it, and that's how you find your reference angle. And that should be, I believe that's going to be 55. Yeah, 55 degrees is equal to the reference angle. So let's go ahead and write that. Theta sub r is equal to 55 degrees. All right, for the next angle, this time this is in radians, but same idea. So you draw the graph. 7/6 pi, if you look at your unit circle, is going to be in the third quadrant, approximately here somewhere. All right, so this is 7/6 pi, and we know that this is pi. That's 180 degrees is pi. So we need to find the reference angle, which is the angle that's made with the x-axis and the terminal side of theta. So the reference angle is going to be the bigger angle minus the smaller angle. So 7/6 pi minus pi. Well, another way to write pi is to call it 6/6 pi. That's the same thing as pi. 6/6 pi, you just got a common denominator. So our reference angle is going to be pi over 6. All right, so now they're asking us to find the exact values of these. So you could use reference angles, or you can just use coterminal angles. I'm just going to use coterminal angles. I think it's a lot easier. So in order to find a coterminal, you would add 2 pi, which is the same thing as 12/6. So if you do that, you're going to get pi over 6. So this problem is equivalent to just finding the cosine of pi over 6. And if you go to your unit circles, pi over 6 is here. Cosine is the x-coordinate, radical 3/2. So it's going to be radical 3/2 is our final answer. All right, the next one, we don't really need to find a coterminal angle. We can just go ahead and locate 5/6 pi on the unit circle and find the tangent of that. 5/6 is here. Tangent is y over x. So y over x is going to be 1/2 times the reciprocal of negative radical 3/2, which is 2/radical 3. Cancel out the 2's, you get negative 1/radical 3 is our final answer. Because remember that tangent is the y divided by the x, the y divided by the x. And when you're dividing fractions, you're really multiplying by the reciprocal. Okay, let's keep going. Approximate to 3 decimal places. So whenever you see the word approximate, that basically tells you that you're supposed to use your calculator. So first thing we should do is convert this to decimal degrees. So recall the way we do that is you do sine of 24 plus 20/60. That's how you convert minutes to decimal degrees. And then the other thing you want to make sure is that your calculator is in degree mode. So verify that your calculator is in degree mode, and then type it in exactly the way you see it. So sine 24 plus 20 over 60, close parentheses, is 0.412 if I round to 3 decimal places. All right, the next problem, same thing, approximate the acute angle to the nearest minute. All right, so in this case, we need to find the inverse tangent. That's how you solve for the angle. And all right, so let's do that. So we're still in degree mode. So we're going to take the inverse tangent of both sides in order to get theta isolated. All right, so inverse tan of 3.7, close parentheses, theta is equal to 74.87599,269. But as you can see, they want us to round to the nearest minute. So if you recall, the way we do that, it's going to be 74 degrees. And then the way you get the minutes is you subtract the 74 that's on your calculator. So on your calculator, just do minus 74 to get rid of the number before the decimal. So your calculator should show just this 0.87. And then you multiply that by 60 times 60. And that's how you get 52.55. So I'm just going to leave that at 53 if I round. Actually, just keep it 52 is fine. Minutes. 52 minutes. So that's what they wanted us to do. They wanted us to find the angle first using the inverse tangent and in decimal degree. Then that tells you 74 degrees. And then in order to get the minutes, you have to multiply the decimal portion by 60. And that's how we get 52 minutes. All right, same thing over here. They want us to approximate to 4 decimal places. So on your calculators, you would do sine 98 plus 10 over 60. And let's see what that is. And if we're rounding to 4 decimal places, I am going to get 0.9899 as my answer. All right, approximate to the nearest 0.1 degree all angles in the interval from 0 to 360. All right, so for this kind of a problem, think of the unit circle. Cotangent is x over y. Cotangent is positive. This is a positive number. Cotangent is positive in 2 quadrants. It's positive in quadrant 1, somewhere over here. And it's also going to be positive in quadrant 3. Because if you have x divided by y, a negative divided by a negative is a positive. And clearly a positive divided by a positive is also positive. So there's going to be 2 answers to this problem. One in quadrant 1 and one in quadrant 3. So what you should do first, since our calculators don't have cotangent, what we can do is convert this to a tangent equation by taking the reciprocal of both sides. So if you take the reciprocal of both sides, you're going to get tangent, because 1 over cotan is tan, is equal to, type this into your calculator, actually, it's kind of an ugly long decimal, so I'm just going to leave it the way it is. You can just leave it that way. You could write out the decimal if you want, but it's just a lot of digits, so I'd prefer to just leave it this way. All right, then we do the inverse tangent of both sides like we did previously. Inverse tan of both sides in order to get theta isolated. All right, so if you do that on your calculators, you should get, let's see, inverse tan of 1 divided by 1.3752. You should get 36.36 let's just round to, they don't really tell us, oh yeah, they tell us to 1 decimal degree. So that's going to be 36.0 degrees. All right, so clearly that's this answer in quadrant 1. In order to find this angle in quadrant 3, well, we know that this is 180, so we're using reference angles. The reference angle is 36 degrees. So in order to get this angle, you would add 36.0 to get this angle. That's using reference angles. So the other answer will be 180 plus 360, which is, what is that, 216, I believe? Yes, 216 degrees. All right, so that is the other answer. So there are 2 answers, one in quadrant 1 and one in quadrant 3. All right. Similarly, this is going to be very similar. This time it's in radian mode. So we have to change our calculators to radian mode. So make sure you do that before anything. And we're going to round to 2 decimal places this time. So let's do the same thing. We're going to take the inverse cosine first to get theta. So if you do that, you're going to get theta equals second cos negative 0.1207, close parentheses. I'm getting 1.69 if I round to 2 decimal places. And this is in radians. But similarly to the problem above, we know that cosine is negative in 2 quadrants. Cosine is negative in quadrant 2 and quadrant 3 because you got negative, positive, negative, negative. Cosine is the x-coordinate. So it's negative in these 2 quadrants. So our 2 solutions are going to be one over here and one over here. Well, this is 0 radians. Pi over 2 is approximately, if you do pi over 2 on your calculator, that's approximately 1.57 radians. Pi is 3.14 approximately. 3/2 pi is approximately 4.71 if you do that on your calculator. And then 2 pi is 6.28 approximately. So this answer that we got from our calculator is in quadrant 2 because it's between these 2 values. So this is our 1.69. Now we got to find this answer. And so once again, our reference angle is going to be this minus this. That's our reference. All right, so our reference is going to be 3.14 minus 1.69, which is 1.45. So in order to get this answer, you have to add 1.45 to 3.14. So let's do that now. 3.14 plus the reference angle is going to be 4.59. And that is our other answer. So we have 2 answers, one in quadrant 2 and one in quadrant 3. And that's how you would do these problems. That is the end of the section.